Good morning, students. Hope you are fit and fine at your places and enjoying our learning material at your homes. Students, as we were doing the chapter Gravitation, so today we are going to continue with the same, and the topics for the today's discussion are: first is motion of object under the influence of gravitational force. कैसे ये gravitational force will influence the motion of an object. Then we will differentiate between the terms mass and weight, and then finally we are going to calculate the weight of an object on the moon. Believe me, today's topic is very interesting, and stay with me until the whole video. So, learning outcomes of the day are: after the completion of the topic, you will be able to, number 1, write the equations of motion for a body under the influence of gravitational force. Means when the gravitational force is acting on an object, then what will be the form of equations of motion? How will they change? We are going to study them. Remember the equations of motion? Yes? Yes, V is equal to U plus AT, S equal to UT plus half AT square, and V square minus U square equal to 2AS. All these three equations will have certain changes due to the gravitational force, and we are going to study them. And after that, we will going to apply these equations to solve the numerical problems. And after the completion of the topic, you will find yourself that you are able to apply these equations to solve the numerical problems. And then we will differentiate between mass and weight. They are not the same synonyms, they are not the same terms. Actually, there is a lot of difference between these two terms, and we are going to differentiate between these. And then we will calculate the weight of an object on the surface of moon. Students, how the motion affects the gravitational force, or you can say how the gravitational force affects the motion of the object. Yes, it affects. As you know that when the object will fall under the action of gravitational force, then it is moving in a vertical direction. So, we are going to take the distance covered by the object as height of the object. Okay. Secondly, when the body is moving under the action of this gravitational force only, then we call it as freely falling body. Remember? So, the body is freely falling. That means the acceleration acting on the body is acceleration due to gravity. So, these are the main changes in the equations. Let's see how. Let an object falls towards the earth with the initial velocity u, and it accelerates with g. Okay, clear why we have taken g? Because it is falling under the action of gravitational force alone. So it will attain some velocity, that is v, final velocity v, in the time t. It covers the distance h. Why we are taking h? Because vertical distance we are taking it as height during this time interval. Let us see, then the three equations will become: here v equal to u plus at nahi hai, here it is v equal to u plus gt. So instead of a we are going to write g. Secondly, s equal to ut plus half at square, but here we are going to write it as h equals to ut plus half gt square. S will be replaced by h and a will be replaced by g. Then last relation, here v square equal to u square plus 2gh. Why? G and h are there. Clear? Let us again revise it. So we have the three set of equations. These are the three set of equations that we have studied in the previous chapters. Let us see. This was our first equation, and this s equal to ut plus half at square, it was our second equation, and 2as equal to v square minus u square, it was our third equation of motion. Now under the influence of gravitational force, what will be their form? First, it will be v equal to u plus gt. Remember it, okay? Instead of a, we are writing g now. And then second equation will be Yes, h equal to ut plus half gt square. Instead of s we are writing h, instead of a we are writing g. And for the third equation, 2gh equals to v square minus u square. Clear? I think it's clear now. So remember these three equations by heart so that we can solve the numerical problems. And one important thing that we need to note is that the value of acceleration due to gravity, that is small g, it is taken as positive in case when the object is moving towards the earth. दो तरह से हो सकता है, object either is moving away from earth or moving towards the earth. So when it is moving towards the earth, then we will take g as positive. And when the object is thrown in the opposite direction of the earth, that is moving away from the earth, then we will take g as negative. And when the body falls freely, we take it as u equal to 0, means when the body is dropped. Okay, no external force is applied, just we have to drop. It is moving under the action of gravitational force only. So we will take u as, that is initial velocity, as 0. And when the body is thrown up, at the topmost point what will happen, this final velocity will be 0. जब हम ऊपर की तरफ कोई चीज को फेंकेंगे, at the highest point it will stop for a moment and then it will move back to the earth. So at the highest point its velocity, that is the final velocity of the body, will be 0. ठीक है? Let's try to solve the numerical. A car falls off a ledge and drops to the ground in 0.5 seconds. Just note that time is 0.5 seconds and we are taking g as 10, otherwise its value is 9.8. Just for simplifying the calculations, you can take g to be 10 meter per second square. Now question 1 is, what is its speed on striking the ground? Means when it is dropped and then it will reach to the earth and just striking the earth, what will be its speed? V हमने निकालना है. What is its average speed during this time and how high the ledge is from the ground? उसका distance, उसकी height कितनी है ground से जहाँ से object गिरा है. So let's see how to solve. Here time is a half second. Initial velocity is 0. Why 0? Because it is drop. The word drop tells us that u is 0. And acceleration due to gravity, we are going to take it as 10. Now it is moving downward towards the earth, so we are taking it as positive. Its vector quantity, we can take it as positive, negative, 0. So it's here it is positive. And we are applying the first equation, v equal to u plus at. Here u is already 0, so we can skip that. V equal to at, and here we get the final velocity of the object is 5 meter per second square. Now for average, it is uniform motion, so we can take the average as u plus v by 2. Here initially it was 0 and finally it is 5. So we are solving it simple, इनकी average निकाली है and it comes out to be 2.5 meter per second. And the last is how high is the ledge, means distance travelled by the car which is falling. So we are taking here the formula, second equation of motion, s equal to ut plus half at square. ठीक है? तो यहाँ पे u is already 0, so we are neglecting it and we are taking only the second part, second term of that equation, that is half at square. Here a is g, that is 10, and t is 0.5. So after solving, we are getting the distance as 1.25, and this distance is actually the height. So s equals to h. So height of the ledge is 1.25 meter. Hope it's clear. Let's take another example. Here an object is thrown vertically upward motion, and rises to the height of 10 meter. At the highest point its velocity will be 0. Remember this, ठीक है? It is moving up to the height, rises up to the height 10 meter. Calculate velocity with which the object was thrown. इसने final velocity तो पूछी ही नहीं, इसने पूछा है with which velocity it was thrown. तो वो हमें निकालनी है, u निकालना है. And the time taken by the object to reach the highest point. How much time it will take to reach this, to cover this 10 meter. Let's try to solve. Whatever the values are given in the numerical, just note down. First is height. So distance traveled by the object is 10 meter. Okay. Then final velocity, as we have seen, vertically upward up to rises up to 10 meter. After 10 meter, it moves down. So its highest point, its velocity will be 0. So v is 0. Acceleration due to gravity, here it is not given that you can take 10. So we have to take it as 9.8 meter per second square, exact value. Now what about its sign? It is here, the body is thrown upward against the gravity. It is against gravity. So 9.8 के साथ हमें minus लगाना है. Okay, negative sign. So let us solve it one by one. Now here first is calculate the velocity with which object is thrown upward. Means u निकालना है. So we are taking this third equation, v square equal to u square plus 2as. Here a is g and s is h. Remember this, okay? So let's apply this. Finally, v equal to 0, u square plus 2, acceleration due to gravity is minus 9.8, and the distance is, that is the height it rises, is 10 meter. So after solving it, you are getting initial velocity is 14 meter per second. Solve it and then tell your answer. Okay? Then second part is the time taken. Let us find the time now. So we are using this velocity time relation. First equation, v equal to u plus at. So here v finally 0 hai, u we have calculated, and a is minus 9.8, जो g है हमारी है ना, and we have to calculate the t. So on solving it, taking minus this 14 to the left side and then dividing it by 9.8, minus 9.8 rather, so we'll get the t as 1.43 seconds. So the time the object takes to reach the highest point is 1.43 seconds. Now the next topic that we have to discuss is the concept of mass and weight. Both are physical quantities, but we generally see that we think both are the same, but actually students, they are entirely different. Here you can see from this diagram, the object has the mass 2 kg in all the three cases, but this is the weighing machine calculating the weight of object, not mass, and you can see the value of the object here. It is every point it is different. Why it is different? Actually, they are placed at different places. The first weighing machine is at Earth, second weighing machine is placed at Moon, and the third is placed in the deep space. So weight of the object depends where the object is. So the values are different. For the first it is 19.6 Newton, second it is weight is only 3.3 Newton, and the deep space the weight is 0. Although the object has the mass 2 kg everywhere, whether it is on Earth, Moon or deep space. So let's explore it. Why, and what is the terms, what are the differences and how it happens. Let's see. So first of all, just let's go through the little definition of mass and weight. Mass of an object is the quantity of matter contained in it. Means how much quantity it has, that is the mass. But weight is the force. Remember this, weight is the force with which it is attracted towards the earth or towards the any other heavenly bodies. किसी भी object की तरफ जब attract होती है कोई body, that force is called its weight. So let's differentiate between mass and weight now. Weight of a body is the force with which it is attracted towards the earth or any heavenly bodies, and we can calculate weight as weight equals to m multiply g. That is mass of an object multiply the acceleration due to gravity. Okay? Now here g is the acceleration due to gravity of earth if we are measuring the weight at earth. If we are measuring the weight at moon, then g will be for the moon. Okay? we'll discuss it further. Okay. Now secondly, it is the SI units of weight is Newton. We have seen in the previous slide it was Newton written. That means it is the force, and that's why it's have the units Newton. Whereas for the mass, it is the measure of its inertia. More is the inertia, more will be the mass, or you can say more is the mass of an object, higher will be its inertia. ठीक है, तो कैसे इनर्शिया को मेजर करना है? बाय द मास, जैसे हमने पढ़ा हुआ है प्रीवियस चैप्टर्स में भी. ठीक है, एंड इट्स एसआई यूनिट इज केजी and it remains constant everywhere. It cannot be zero. जो है मास, किसी क्वांटिटी अगर कोई मैटर है उसमें तो उसका मास कुछ ना कुछ होगा, and that will be the constant quantity. Mass is constant, it cannot be changed. ठीक है, but the value of the weight changes from place to place. It can be positive, it can be even negative, and it can be zero also. We'll discuss it. Okay, then mass is measured by beam balance. Okay, when the beam balance is measuring, it is measuring the mass, but when we are measuring with the spring balance, it is measuring the weight of an object. Remember, spring balance measures the weight of an object. Then mass has only the magnitude because it's not a vector quantity, it is a scalar quantity. And weight on the other hand, it has both magnitude as well as the direction. That means it is a vector quantity. So I hope you know the difference between mass and weight. Okay, so see this picture here. You can have a little bit idea. Here the astronaut has the mass 120 kg. Now it is on earth. When it reaches on the moon, its mass remains 120 kg. Okay, mass will not change. Now here the weight of the astronaut is 120 multiply g, that is on earth it is 10 small g. So weight of object is 1200 Newton. The mass of this astronaut was 120 kg, but its weight is 1200 Newton. Okay, but on the moon the weight is 200 Newton. Here समथिंग इज डिफरेंट, कुछ है इसका जी डिफरेंट है. कैलकुलेट करेंगे हम, देखेंगे कैसे आया ये डिफरेंट. सो स्टूडेंट्स, एज यू नो दैट वेन एवर यू वे योर मास, यू ऑलवेज से आई एम 40 kg, आई एम 50 kg. एक्चुअली दैट इज योर मास, इट्स नॉट योर वेट. आप ऐसे ही बोलते हो मेरा वेट 50 kg है. दिस इज रॉन्ग. योर मास इज 50 kg and your weight will be 10 times of that. Means if you have the mass, जो आप वेट बोलते हो, एक्चुअली दैट इज योर मास. इफ योर मास इज 50 kg on earth, then your weight is 50 multiply 10, that is yes 500 newtons. Okay, so next time whenever you weigh, remember you have to say your mass is this, not weight. Okay, so let's calculate weight of object on moon. अब moon पे वो क्यों कम आया था वैल्यू, let's discuss it. Now weight of object on the earth is force with which earth is attracting, and weight of object on the moon is the force with which moon is attracting that object. Okay, ये हमने पढ़ लिया इसकी डेफिनेशन बाय डेफिनेशन, वेट की डेफिनेशन से. Now mass and radius of moon, both mass and radius of moon is less than that of earth. छोटा है ना moon, तो उसका mass भी कम है, उसका radius भी कम है. So the moon exerts lesser force on the object. उसकी जो gravitational force होगी on the object will be lesser when the object is near it, and when the object is near the earth it's greater because earth is bigger. ठीक है, तो कैसे होता है, let's see it. Let's find the relation कि weight of object on moon and that of the weight of object on earth. What's the relation? So we have to use this data. Mass of earth is nearly 6 into 10 raised by 24. Because it's 5.98, we'll take it as 6 also. Then radius of earth is 6 into 10 raised by 6 meters. Okay, and moon, in case of moon, its mass is you can see 100 times कम आ रहा है ना, almost 24 है, यहाँ power 22 है. तो it is 7.36 into 10 raised by 24 kg, and the radius is 1.74 into 10 raised by 6. How small is the moon in comparison to earth, है ना, you can see. So let's take the mass of object to be m, जो जिसने moon पे भी जाना है earth पे भी जाना है, उसका mass हमने m ले लिया है. And let's its weight on the moon is wm. W is for weight and M is for moon. And let's the mass of moon be this mass of moon we are taking it as M, capital M, सफिक्स में स्मॉल m डाल दिया कि ये मून का मास होगा और रेडियस उसका ये जो हमने ले रहे हैं 1.74, तो उसको हम rm से डिनोट करेंगे. तो बेटा वेट का फॉर्मूला हमने अभी अभी किया, वेट वाज m इंटू जी, याद है, वेट इज इक्वल टू m इंटू जी. तो बेटा g का फॉर्मूला जो हमने पहले कैलकुलेट किया हुआ है दैट इज gm अपॉन r स्क्वायर. Small g is equal to capital G m upon r square. So here this part g m upon r square is actually the small g. ठीक है. So for moon the value of weight can be written as like this also, and for the earth we can write it as g m upon r square. ठीक है जी. Let's substitute the values and we'll find that on substituting the value the weight on moon comes out to be we are filling the values that from the data, and it comes out to be 2.431 into 10 raised to 10 g into m. Why we are not filling these values? Because we have to compare it with earth, and for earth also mass of object will remain same and g is also universally same, so g will also remain same. So while comparing these, we will cancel these g and m. So and when we substitute the values for earth, we get this value gm again as such. Now let's compare these two. So while comparing wm and we, while dividing these two, we get gm get cancelled with gm, and on solving this beta we get the answer to be 1/6. It is just the calculated value. ठीक है, आप ट्राई कर सकते हो इसको सॉल्व करने के लिए and your answer will going to be come like this. ठीक है, so otherwise you can memorize it also कि weight of object on moon upon weight of object on earth is 1/6. तो यहाँ से हमें समझ आ रही है कि when the object will move from earth to moon, its weight will decrease by 1/6. इसका 1/6 रह जाएगा वेट, डिक्रीज बाय नहीं 1/6 टाइम्स हो जाएगा, मीन्स 6 टाइम्स कम हो जाएगा वेट उसका. द वेट ऑफ ऑब्जेक्ट ऑन मून विल बी 1/6 द वेट ऑन अर्थ. अगर आपका वेट अर्थ पे 60 kg इंटू 10 दैट इज 600 न्यूटन्स है, तो वेट ऑन मून कितना हो जाएगा 600 न्यूटन डिवाइडेड बाय 6, दैट इज यस 100 न्यूटन्स ओनली. ठीक है, 1/6 हो जाएगा. तो अब इसको मास से पहले कंफ्यूज नहीं करना है. मास आपका अगर 60 kg अर्थ पे है, मून पे भी 60 kg ही रहेगा, लेकिन वेट बिकम्स 1/6 ऑन द मून. ठीक है, तो वेट के लिए ध्यान रखना है, उसके यूनिट्स न्यूटन आएंगे. तो MCQ के लिए बहुत इंपॉर्टेंट है यहाँ पे मास और एंड वेट का कॉन्सेप्ट दिमाग में रखना है. वेट इज अ फोर्स एंड इट इज मेजर्ड विद इन न्यूटन्स. मास इज the quantity of matter and it is measured in kg, and weight of object will change when object is moving from earth to moon and it becomes 1/6, ठीक है, of its weight on earth. But remember, mass of object will not change whether it is on moon or earth or any other place, anywhere in the universe, mass will remain the same. ठीक है. So let's apply our knowledge to solve the numericals. Mass of the object is 10 kg. Weight, what will be its weight on earth? अब सिंपल सी बात है, वेट निकालना है तो इसको मास को कैसे निकालेंगे अभी हमने सीखा. Yes, we are going to apply the formula W equal to mg. तो पहले जो हमें given है we'll write that mass m is 10 kg and g is 9.8 meter per second square. It's not given, we have to take every time it's fixed value for earth. So weight will be 10 multiply 9.8 that is 98 न्यूटन. ठीक है, क्लियर, बहुत इजी था. लेकिन अगर यही पूछ लिया जाए व्हाट विल बी द वेट ऑफ ऑब्जेक्ट ऑन मून, तो कैसे करेंगे. जो भी आपका आंसर आएगा यहाँ पे दिस इज ऑन अर्थ, तो ऑन मून निकालने के लिए यू कैन डिवाइड इट बाय 6, सिंपल, क्योंकि हमने सीख लिया है कि वो 1/6 रह जाएगा. सो लेट्स सी द अनदर एग्जांपल. An object weighs 10 Newton when measured on the surface of earth. So what will be its weight when measured on the surface of moon? Same question आ गया ना, अलग से उसने पूछ लिया कि weight is 10 Newton and what will be its weight on the moon. सो हमने 1/6 करना है. रिमेंबर द इक्वेशन अभी हमने की सीखी है. वेट ऑफ ऑब्जेक्ट ऑन मून इज 1/6 इट्स वेट ऑन अर्थ. सो 1/6 मीन्स इसको 6 से डिवाइड करेंगे. सो वेट विल बिकम 1.67 ऑन मून. ठीक है जी. सो that's all for today, and try to solve the back exercise questions number 12 to 18. They are on the page number 144 of your NCERT book. So please take the help from the video, and I am sure that you are able to solve all these questions. For further query, you can ask me anytime, dear. So, thank you class. Thank you and have a nice day.